Okay, this is my solution video to quiz number 1. So the first thing we want to do, of course, is to draw ourselves a little picture. You may, of course, use Desmos to do this. And if you use Desmos, you're going to get something that looks like this. And, of course, you need to find this point right here. And so you can obtain that point by setting the two equations equal to each other, or by graphing it in Desmos and taking a look at what Desmos has to say. So we end up with 2x squared equals 8, or x squared equals 4. X equals plus or minus 2. We only care about the positive one. So this point right here is 2. So our region R, and let's put our axis here. There is 4. And so we are rotating the region R around the line x equals 4. So we need to find the bounds of integration. And we pretty much just did that. We know that we will be integrating the bounds are going to be x is less than or equal to 2, greater than or equal to 0. The next thing I need to do is find the radius, because the easiest way to do this, of course, is going to be to use cylindrical shells. Okay, so I'm going to have a vertical rectangle, which the axis of the length of that rectangle is parallel to the axis of rotation, which is what you want when you're doing cylindrical shells. So the radius, so this distance right from here to the axis of rotation is going to be the distance 4 minus the distance x. So radius is 4 minus x. And again, in case you didn't get that, and I'm sure by now you guys have got that. So distance along this orange line is the distance 4. And the distance along the smaller orange line is the distance x to the center of the rectangle. So the distance from the rectangles to the line is 4 minus x. Finally, we want the height of the rectangle. And the height of the rectangle is simply going to be the difference between the two curves. So that's going to be 8 minus x squared, which is 8 minus 2x squared. Next step would be to put it all together into our integration formula. So volume is going to be 2 pi times the integral from 0 to 2, my bounds of integration, times my radius, times my height of each rectangle. And so what I would do now is enter this into Desmos. And I do believe I did enter it into Desmos. So I did it on my laptop. I did not do it here. But it is the correct integral. Once you get your integral set up, always just check it in Desmos. And then when you get your final answer, check that against your integral. So now we have volume is 2 pi times the integral from 0 to 2. And so very carefully, we're going to multiply these together. We get 32 minus 8x minus 8x squared plus 2x cubed dx. And now we can integrate. Volume is equal to 2 pi. And so we have 32x minus 4x squared minus 8/3 x cubed plus 1/2 x to the 4th, evaluated from 0 to 2. And plugging 2 into all of this, we get 2 pi times 32 times 2 is 64. 2 squared is 4 minus 16 8 thirds, so 2 cubed is 8, so minus 64 thirds. And x2 to the fourth is 16 times 1/2 is 8. 64 minus 16 is 48, plus 8 is 56. So we have 2 pi times 56 minus 64 thirds. And 56 is 168 thirds minus 64 thirds times the 2 pi. And now volume is 2 pi times 168 minus 64 is 104 over 3. So volume is 2 times 104 is 208 pi over 3. And there is the answer that I want in simplified in terms of pi. Now, if you put this in Desmos, it is going to give you an answer of 217.817. And so if you, when you put the integral in your integration problem setup, it'll give you 217.817. And when you put 208 pi divided by 3, it will give you 117.817. All right, so that's it for quiz number 1. I hope you had fun with that.